Hello everyone, good evening and welcome to North Star. Today in this lecture we are going to start with a new topic. Topic 4 of section 1F, Data Analytics. Let's get started. Data Analytics, this is the last topic of section 1F and a simple as well. Data Analytics involves the systematic computational analysis of data or statistics to discover, interpret, and communicate meaningful patterns and insights. It transforms raw data into valuable information that aids in decision making and strategic planning in various domains from business to healthcare. Basic introduction. What do we need to go to? We need to understand what is big data. What is big data? Break the words into two parts, data and big. Data, we all know it's a raw form of information. When the data is raw, we call it data, or when any information is in the raw format, we call it data. Once they convert into a meaningful format which is readable, understandable, we call it information. Now big data, as the name suggests, it's a large volume of data, some terabytes of data together, very big large volume. Imagine data that is generated on Instagram on a daily basis. Imagine data which is generated on YouTube on a daily basis, or Facebook, or Twitter, or LinkedIn on a daily basis. That kind of data we are talking about, or Flipkart, Amazon, Indian Railways. How much data is being generated on a per day basis? At the back end, whatever we are getting, that is what we call big data. Huge amount of data. Big data refers to data sets which are extremely large or complex. Big data is also too large to be analyzed by traditional data analysis software. Normal software will not work. If you think Excel and all that, no, all that will not work. Put 100,000 line items on Excel will collapse immediately. So by traditional data analysis software, and requires some special software with special computational power for processing and analyzing those data. Big data is used to gain insight into relationship and patterns and behavior and consumer behavior, so that some relationship can be established, some pattern can be established, and that can be used for better decision making, increasing sales, increasing matching with the customer purchase pattern or their consumption requirement. It can be broken into four dimensions. These 4 dimensions are very, very important. I want you to remember from exam point of view. First is the volume of data, then velocity of data, then variety of data, and last is veracity of data. Volume of data, as the name suggests, it refers to the scale at which the data is generated. It entirely refers to the scale at which the data is generated. Big data is just big. There's a huge amount of data. So what is volume? You should know it's about the volume, it's about the quantity of data. Velocity refers to the speed at which big data is generated and analyzed. All right, it refers to the speed. Velocity, I'm sure all of you know, it refers to the speed at which the big data is generated and analyzed. Particularly, I have given you so many examples where daily, terabytes together of data is generated at a global level. Then variety. Variety means what are the different forms of data? Is it only Word document? Is it image? Is it combination of videos, word, images, and so many other things? So variety means big data comes in many different formats. It can be a video, it can be databases, video, social media exchanges, email, health monitors, and more. These are the different variety in which data is created. Remember, the more the variety of data, the more difficult it is to manage the data. And veracity, most important point today. Veracity refers to the truthfulness or the accuracy of the data that is generated. I want you to remember all the 4. Very, very, very important from exam point of view. You should be able to identify the difference amongst all the 4 points. Then data structure. Data can be structured or organized in several ways. Structured data has fixed fields, such as data organized in spreadsheet. So simple spreadsheet, Excel, I'm sure all of you know that we have columns and we have rows, and that's a simple structure of data in columns and rows. That is very well organized. So we call them structured data. Then we have semi-structured data, which is not so beautifully organized in the form of columns and rows, what we see in Excel. So semi-structured data does not have a neat organized fields like structured data. So they are not as bad as unstructured, but not as good as structured data. So structured data are all very well organized in the form of rows and columns, and you are able to analyze it and take decisions. Semi-structured, not so beautifully organized. And then we have unstructured data. So what is unstructured data? It is a complete unorganized data which you cannot take any decision. It is a raw format of the data which can have so many things in combination of image, words, videos, text messages, photos, so many things. So information from Twitter feed, text message, photos, videos are examples of unstructured data where everything is in a mixed format. There's no proper organization of the data. From data to action. Now, how do you take from data, how do you take action? In simple words, from data, how do you convert the data into meaningful information so that option can be taken, all right? So that meaningful decisions can be made, all right? So business intelligence is all set of applications, tools, best practices that transform data into actionable information. Actionable information means information which is going to help us take better decision. Then data by itself has limited meaning. In the sense that data, if it is in the raw format, it has almost no meaning unless you convert into rows, columns, formats in a very specific look so that it can be analyzed using so many different softwares and tools. And data analytics come into place. What is data analytics? Basically analyzing the data, in going very, very deep into data, understanding correlation, understanding pattern, understanding any kind of trend, which is going to help us gain some meaningful insights, which is going to help us take a proper or take logical business decision based on what the data speaks. Because there's a saying, data does not lie, right? When done properly, data analytics can become a strategic asset because it will help us go deeper into everything and take sound decision for achieving the objectives of the organization. Then we have data mining. What is data mining? Again, same thing. We have big volume of data. What do? We go deeper and deeper and deeper into the data to find some meaningful insights, some meaningful pattern, behavior, correlation between X and Y, correlation between different consumers, how or their purchase pattern. It can be anything. If Amazon is or Flipkart is trying to analyze data, they are going to analyze data, what kind of product consumers are buying, what is their age group, male, female, gender, location, what is their annual spend, monthly spend, which season they are spending more. All these, there can be hundreds and hundreds of analysis to gain some insight. And once the way that we do is what we call data mining. So data mining is used to reveal some patterns, and insights, typically from large data sets. Data mining involves statistical method, computer learning, artificial intelligence, and large-scale computer power to analyze large amount of data in order to extract meaningful information about relationship, trends, patterns, and any anomalies. The primary goal is to provide useful information for decision making. This is the most important objective of data mining. And data mining can be challenging because of many reasons. The first most important reason is the quality of data. Is the data, is the quality good? Is the data reliable? If the data quality is good, data is reliable, then whatever decision you will take will be good. If the data itself is not reliable, then decision can be faulty. And similarly, data mining involves enormous data set. This is just for your reading, nothing from exam point of view, just for your information to understand in complete sense what do you mean by data mining and how can it be challenging. The most important reason data mining can be challenging is the veracity of data or the quality and authenticity of the data. Similarly, for data mining, because we are using large volume of data, we need advanced technology, advanced computational ability, advanced server, advanced processing units to be able to process that kind of data. If you have ever used Excel with large volume of data, you will see that the moment the number of line items exceed 100,000 or maybe 50, 60,000 also, the moment it increase, Excel will keep collapsing. It is not capable of handling such a large volume of, in fact 100,000 is not large at all, but it is still not capable of handling that much data. Here we are talking about much bigger data sets. A simple computer, what you see at home, will not be able to process that much data because it involves huge database. It involves enormous use of advanced software technology, having extreme computational capabilities. So those are some of the challenges in data mining. Similarly, data mining involves specific tools to manipulate and extract information from the database. SQL, you need to know, is a structured query language. It's a standard programming language used to communicate with the database. All right, it can be used for performing various functions with the databases. So you need to know what is SQL, a little bit about SQL. I'm sure many of you must have heard either as SQL or what we popularly call as SQL. All right, so just a basic of what is SQL. All right, just remember it. It can be tested in exam as one of the options. So you need to know all the 4 options. It's difficult in this topic or entire section F to know all the 4 topics because it can have technical words. Then fitting analytic models. Analytic models are the empirical or data-driven approach to understand connections, effects and outcomes. Underlining analytic model is a question about how one factor is affecting another. It's basically what we call it understanding patterns, understanding correlation, understanding some kind of relationship between X and Y, some kind of relationship between this and that. That is what we do in the entire analysis. Is the relationship positive or negative? Do 2 factors have significant statistical association? Are they connected to each other through some way or the other? All these are some of the analytical models. Types of data analytics. Now this is very important. I want you to remember this entire thing. Types of data analytics. So first one is descriptive. All right, first one. This form of data analytics aims to answer the question what or what was. All right, what or what was. Descriptive. It tells. Descriptive data analysis is observational and reports on the characteristics of historical data. It reports on the characteristics of historical data. I want you to remember here it answers what is or what was, what has happened, or what was the information all about. It is like, it describes statistical properties such as mean, median, range, standard deviation. So it gives you a complete information about what the data speaks. All right, whatever the data contains, it just tries out to understand what it tries to convey. That's all it tries to say, which is descriptive. What is or what was in the data, what you found, what you analyzed. Diagnostic is going deeper. Suppose you found, lot of people who bought X, 70% of them also bought Y. All right, 70% of them bought Y. So let's say there is a product, all those people who bought X, 70% of them also bought Y. So this is what is the fact. So descriptive is like determining a fact from the data. Now the next analytics is diagnostic. In diagnostic, we try to find out reason why did this happen, why this happened, why 70% of the people who bought X also bought Y. Why did this happen? What is the reason behind it? Is there some connection between these 2 products? So this form of data analytics aim to answer why did this happen. All right. Diagnostic data analytics look at correlations. the size and the strength of statistical association. It can help identify empirical relationship that may be unknown or uncertain. So it tries to understand some kind of relationship that we were not aware. That is diagnostic, finding why it happened. What happened? Descriptive. Why it happened? Diagnostic. Now, once we have understood why it happened, then we try to understand in the future what will happen. All right, in the future what will happen. So we call it predictive. Predictive is what will happen. Now that we know what had happened, now we know why it happened, we need to understand what will happen in the future, because now we understood the past data. So prescriptive analysis builds upon descriptive and diagnostic analytics to make predictions about the future events. So once we have looked into what had happened, we looked into why it happened, we want to understand what will happen in the future so that we are ready. So now that we understood anybody who has bought X, 70% chance that they have also bought Y. If I want to increase the sales of X, I must ensure that I also increase the inventory of Y. Alright, so if I am trying to increase the sales of X, I must also push the inventory of Y, because I have understood 70% of the people who buys X also buys Y. So Y's demand will also increase when I try to push the marketing and sales for X. Who told me? Predictive. So I'm planning for the future. Then prescriptive. This form of data analytics aims to answer what should happen. So here we understood what happened, we understood why happened, we understood what should or what will happen, that is predictive, and finally prescriptive, what should have happened. So what should have happened is basically based on all the data analytics that we do. We understand, okay, this has happened, but actually this should have happened as the data suggests. So prescriptive analytics draws upon the other forms of data analytics to infer or recommend the best course of action. Prescriptive analytics can take the form of optimization or simulation analysis to identify and prescribe the actions to undertake to realize the best or the most desired results. So it tells us what should have happened based on what the company wants to achieve. It tells what could be the most optimal outcome based on so many different fact patterns. Right? So I want you to know the difference between all the four. It can, very heavily tested in exam as a MCQ question or as a case study question. Both can be heavily tested. MCQ and case study, one of the two is quite certain. When to use analytical models? Clustering. Clustering is a data analysis technique that involves grouping similar objects together. It's like creating a ledger for sales, ledger for purchases, ledgers for sales return. It's like grouping all of it together, which has similar objects, which has similar fact pattern. So clustering is focused on the discovery and identification of patterns of similarity and dissimilarity. So just in exam, don't try to write a lot. Write some keywords, write some technical meaning in your own words. Explain in very simple meaning, emphasizing on the fact that its core meaning comes out in your explanation in the shortest possible words. Then we talk about classification. Classification is data analysis technique which attempts to predict which category or class an item belongs. So classification typically begins with predefined categories and then attempts to sort an item into one of those categories. So we classify, all the sales go together, all the purchases go together, and then we, I hope you remember recording. Accounting is an art of recording, classifying. So clustering is grouping all sales together, classifying, putting them in sales ledger, all of them together. So that is what it's like, going through journal entry. Okay, this is sales entry, it will go to sales. This is purchase entry, it will go to purchases. So we have done clustering. Then we are moving them to each ledger. We are doing classifying. Regression is when we are trying to analyze and understand some pattern and some relationship, correlation. So regression is a data analysis method of analyzing correlation of the outcome between an independent variable and a dependent variable. I hope you remember independent variable, dependent variable, and correlation can be, simple correlation